Hey everybody, Zach here. Wanted to give you a video on some additional formulas that are not on your formula sheet that you might want to have because they have been used on recent exams. So I'm going to go just one topic at a time here. So first of all, dealing with polarizers. It's a polarized sheet. So you have basically one equation in your formula sheet. The one equation is when you go from polarized light to polarized light, where I is equal to the previous intensity times cosine squared of the angle. That is the angle relative to the angle of it hitting it versus the next polarizer, or from polarizer to polarizer. That is fine. But if you have unpolarized, like scattered light, like sunlight, if they would say it's unpolarized and it goes through a polarizer, then the other equation you need is you need to know the intensity just gets cut in half. So that's one of the formulas you need to know. Next up, I want to talk about this equation: force equals mu naught I1 I2 L over 2 pi R. Where did let's see, yeah, where did this one come from? Well, you have force of a current carrying wire, BIL, and then you have the magnetic field around a current carrying wire, mu naught I over 2 pi R. So what happens is if we have like two wires, actually as an extra side note, wires with current going in the same direction have opposite magnetic fields in between them, which means that these two wires would have an attractive force. You have to know that as well. But in general, what happens is this wire on the bottom is creating a B field around it, and this wire on top is creating a B field around it. That's going to hit the other wire. So this is the external field that's hitting a current carrying wire, but that external field is coming from the other wire. So by substituting it in, that's how they got mu naught IIL over 2 pi r, where r is the distance between the two wires. That's effectively the radial path from one wire to the other. So this equation historically is not on your formula sheet. Make sure you have that one down, and that has been used in recent exams from the past 2 years. Next up, Young's double slit experiment, okay? Do y'all remember Young's modulus from like Physics 1? It's the same person, just so you know. So what happens is we have D, which is the distance separation between the two slits, and this would be two light sources or waves or EM waves or water waves that would hit a screen of length L away, and there'd be a distance Y up where the bright and dark fringes would occur. Well, first of all, that angle would be Y over L equals tangent of theta. This formula is not on your formula sheet historically. So again, opposite over adjacent. L is the distance from the slits to this screen. Think of it like a wall almost, that the bright and dark fringes are going to occur. And then you have the equation d sine theta equals m lambda. For a small enough angle, you do have in your formula sheet that these are roughly equal to each other. And the reason why is because tangent is sine over cosine. And when you get really close to 0, cosine of 0 is equal to 1. That's why they're really close to each other. Nevertheless, good time word, we would go ahead and substitute this in for each other. And we would get, and you have to divide that d over to do that. So you would have, again, one equation, y over L equals tangent of theta. I've used that one on a recent exam. And then we would have y over L equals m lambda over d, or y equals m lambda L over d. So these two equations you'll need to put on your formula, or need to know. Beyond that, last thing I'd recommend is the 4 right-hand rules. Here are my little right-hand mittens, right-hand mittens, right-hand mittens. So we start with force equals QVB sine of theta. V is your thumb, your fingertips are B, where he pushes your force, but this is the one time where if the charge is negative, you have to switch the missing component, switch whatever is missing. So if you have like the velocity and the force, you're trying to find the B, you use the right-hand rule, but then if, let's say the answer for B is positive Y, for the negative charge, it would be the negative Y, be the opposite direction. Then you had force equals BIL sine of theta. So I, B, where he pushes a force. And then you had, when you had an electromagnetic field, because that's really what it is, B equals E over B, it would be E, B. Basically, your fingertips are always B, in case you didn't figure that out, and where he pushes your velocity. And then lastly, you have the whole curling concept, where effectively you basically had your thumb was your current, and then your B, your fingertips would curl. But beyond that, I actually would just draw the wire and say, okay, if current's going this way, thumb goes to the right fingertips, right hand fingertips go out of the page above and into the page below. And then just rotate that if you want to go like left, right, up, or down. And then if you had a wire going out of the page, this is a current carrying wire coming out of the page at you, out is counterclockwise for the B field. Okay, I forced the rhyme. And then lastly, you have a loop with a counterclockwise current. Out is counterclockwise. The B field is actually out of the page inside, and it's actually into the page outside. They just ask for the general direction. Okay. It's actually just taking this over here and just doing this, by the way. That's really what I'm doing overall. So between this page, make sure you know your 4 right-hand rules, 2 extra equations for double slit, polarizers from unpolarized to polarized, and force between 2 current carrying wires that are parallel to each other, a distance r from each other, and a length L would be given. That is the extras I'd recommend you remember when you start the test from memory, write them down. 1, 2, 3, 4, and a big 5. Good luck.